Our next example is to use the cylindrical coordinates to find the mass of the solid Q of density rho. And Q is the region of the points where Z is between 0 and 9 minus x minus 2y, and the circles, the circular region, x squared plus y squared less equal to 4. So this time finding the limit is actually pretty easy. And why I'm saying this thing, if you think, then your Z values are between 0 and 9 minus r cosine of theta minus 2r sine theta. That's what your limits of Z is going to be. Whereas x squared plus y squared, as I said, this is the circle of radius 4 unit. So what does that tell me? That my r, because the radius is 2, so you will say it is between 0 and 2 units. And the theta, being a full circle, is going to be in between 0 and 2 pi. So those are all the limits that I have to worry about. So what I'm going to do now, I'm going to go ahead and say that this mass, the required mass, is going to be, remember, it's integration. So let's say integration of theta at the end, so 0 to 2 pi, integration 0 to 2 is the limits for r, and integration 0 to 9 minus r cosine theta minus 2r sine theta is Z's limit. And I'm using the cylindrical system, so we're pretty good with this setup. And then remember this r that comes from the Jacobian, and then you have the density function, which is k times square root of x squared plus r squared is also r squared. And then you have dz, dr, d theta. So let's start working on this antiderivative. So first and foremost, I will take this k out, and I will get antiderivative 0 to 2 pi, 0 to 2. And then I can start doing the antiderivative. I will get r. So if you want, I will write one more step. 9 minus r cosine theta minus 2r sine theta. And this is r squared dz, dr, d theta. So k times integration 0 to 2 pi, integration 0 to 2. And when I do the antiderivative with respect to z, I just get z. So it's r squared times z within the limits of 0. 9 minus r cosine theta minus 2r sine theta, dr, d theta. So let's put in the values for the limits of z. So I get k times integration 0 to 2 pi, integration 0 to 2. And for z, you will get r squared times 9 minus r cosine theta minus 2r sine theta. Okay? dr, d theta. So I'm going to distribute, and then next step we're going to do the antiderivative 0 to 2 pi. Integration 0 to r, as I said, I will distribute, so we'll get 9r squared minus r cubed cosine theta minus 2r cubed sine theta dr and d theta. Okay. So I get equal to k times integration 0 to 2 pi. Let's do the integration with respect to r. You get 9r to the power 3 over 3 minus r to the power 4 cosine theta over 4 minus 2r to the power 3 over, actually 2r to the power 4 over 4 sine theta, and I get d theta after I plug in the limit 0 to 2. So this is for all of this. So let's put in r equal to 2 now and see what we get. Because r equal to 0 is not going to contribute, so don't worry about that. So let's see. I get k times integration 0 to 2 pi. Now 9 over 3 is 3. So you get 3 times 2 to the power 3 minus 2 to the power 4 times cosine theta over 4. I can already cancel the 2 and 4 and get 2 on the bottom only. And I get 2 to the power 4 over 2 sine of theta, d theta. Let's simplify for one more step, and I will get k times 0 to 2 pi. 3 times 8 is 24 minus 2 to the power 4 is 16 over 4, so 4 cosine theta. And then you get 2 to the power 4 is 16 over 2, so minus 8 sine theta, and then you do d theta. So now we are taking the antiderivative with respect to theta. So we'll get k times 24 theta minus 4 sine theta plus 8 cosine theta, and the limits are 0 to 2 pi. So we're going to put theta equal to 2 pi. So if I put theta equal to 2 pi in the first one, I get k times 24 times 2 pi, and this is going to be, when you put 2 pi for your theta, you get 2 pi, and 0 is not contributing. Sine of 2 pi is going to be 0. Sine of 0 is 0, also not contributing. Cosine of 2 pi, so I will get plus 8. Cosine of 2 pi is 1 minus cosine of 0, which is 1 as well. So 8 times 1 minus 1, and that portion is going to be 0 as well. So what I get 24 times 2, which is 48 k times pi as the mass of this given three-dimensional figure.